Hello everyone. So today I will be explaining about the topic of matrix multiplication and Strassen's theory. So many of you might not be quite familiar with matrix multiplication as it is a subject you will learn in high school, and I just like to first explain the basics of it. So a matrix is essentially a couple values written in a rectangular notation as you see here. And this particular matrix is what you call a 2 by 2 matrix, which has two rows and two columns. Multiplication, which is in the name, is when you multiply two matrices, and coincidentally here we have another 2 by 2 matrix. And when you multiply these two matrices, you'll have a resulting matrix that is also a 2 by 2 matrix, but the values inside will be completely different. So you guys are probably wondering, wouldn't this take quite a while if you were to have really, really big matrices? Well, yes, it will. So, there's this guy named Strassen who basically developed this theory. Instead of multiplying all those different matrices out and to achieve your resulting matrix, he decided to put them in simpler terms by only needing to multiply on 7 different occasions. So he labeled these 7 terms P1, P2, P3, etc., all the way to P7. And basically, you will start by creating variables on your terms, as you see here A, B, C, D, E, F, G, H. And these variables are just actual values in your matrix. And by using this kind of definition that he has created, you basically turn this problem into more of a plug and chug question. And once you figure out all these values, you plug them into P1, P2, P3, P4, P5, P6, and P7. You can just follow the steps here and receive the resulting numbers in your matrix. So, now that we have the basics down of Strassen's theory and matrix multiplication, we can talk about some of the interesting things that people use in real life with Strassen's theory. So, the first thing I'd like to address is uh, 3D animation, 3D videos, movies, and camera work pretty much. So usually when we take a picture of something, like any object, that's what we call, there's always parameters that have to be filled, and these are the camera's parameters. But you might not have known that these parameters are actually measured in matrix form. And this can remove distortion found in certain images, which is basically like taking out blur from some images, making them clearer. That's how you get all your higher definition photos from today. And on the side of 3D animation, you might not know that when you're converting 2D to 3D videos, uh, you actually use a form of matrix multiplication, but the computer will code it for you. However, this will take quite a while. So you plug in Strassen's theory into your code to create a more efficient and simpler way to do a matrix multiplication problem. And in the 3D realm of things, it'll create a 3D video in a much shorter time than if you were to use the older method inside of your code. Strassen's algorithm also plays an important role when you learn physics. When solving different problems involving like huge matrices, uh, such as like when you're trying to find average force or gravity force, um, this algorithm will help us multiply the path matrix by the gravity matrix within a short span of time. Because when you're looking at the physics of an object, it's actually quite complex, and there will be many different forces acting on it. So instead of trying to use the more orthodox way that is a lot slower, you can use Strassen's theory to quickly solve the problem. Lastly, I'd like to mention that Strassen's algorithm wasn't just an algorithm that made things easier. It was literally that, but in the matrix multiplication realm of things, he also gave way to this new algorithm called the Coppersmith-Winograd algorithm. And it is an even quicker way and more effective way to do matrix multiplication problems. And Strassen's algorithm actually served as an inspiration and a tool that could be used. Thank you guys so much for watching, and I'll see you guys next time.